Hardware has actually come a tremendous amount in the last 20 years, right? Robot arms, batteries, GPUs, LiDAR, all these things are way better now than they were 20 years ago, like orders of magnitude better. What's been missing is the glue to link these two worlds together, right? The software world has improved dramatically over the last 20 years. The hardware world has improved dramatically over the last 20 years, but the tools that link them together have not. And that's what VIAM is here for.
Hi, Eliot. Welcome to Software Engineering Daily.
Hi. Thanks, Pavel. Great to be here.
Great to have you here. So let's begin with the first question. What is VIAM and what do you guys do?
VIAM is a robotic software platform. So we make it much easier to actually write software that interacts with hardware, build a real production robot, then build a real business around that, scale, add features, etc. We make any software engineer able to work with hardware, make it easier for hardware engineers to describe what they've built in software in a simple UI rather than writing code, and have them build real products.
Cool, awesome. And you, as Eliot, what were your first steps that kind of led you on this path?
So after I left MongoDB in the database space, I was looking for interesting problems. I was looking for things that would actually matter. And a lot of the things I started looking at ended up being labor challenges. So think about climate change. Some of the things you want to do in climate change: plant a lot of trees, clean the oceans, remove plastic from the ocean, maybe make 1 million kelp farms. I don't know. All of these things are labor challenges, right? It's hard to get people to do the work where they need to be done, how to do it cost effectively, how to just scale it at all. Other problems, simple other problems like getting my kids to clean the dinner table. All these things are labor challenges. So then I started looking at robotics and robotics as a whole, and started deciding that, hey, look, there are fundamental issues in robotics that are hard to solve, and that let's go and make it easier, right? Let's go make it easier for software people and hardware people to work together to put robots into the world. Let's make it easier to make these things happen. Let's make it easier to build businesses around robotics, and so that innovation happens and that things get better.
So my background is in software engineering. I have built one robot in the past, but that was during my university time. If I would want to get into robotics right now and use VIAM, what would be the hardest and the most time-consuming bottlenecks of programming robots that VIAM would solve?
So there's a lot of different things, if you think about it, and at different stages. Most software people I've met, and this was me for my entire software career, are intimidated by hardware or don't even know where to start. Right? I don't know if you have ever done any hardware tinkering. Right. But I'm sure there are things in the physical world, whether it's in your house or outside, that you'd be like, I wish I could solve that. Right? Maybe it's watering your plants. Maybe it's playing with one of your pets. Who knows? All these things are practical to do with hardware, but you don't know where to start. And part of the reason is there aren't standard APIs, right? There aren't standard APIs for how do you turn a motor on? How do you talk to a camera? All these things are complicated. The languages don't make it easy. The tools don't make it easy. Debugging isn't easy. What hardware to use is sort of not obvious. So the first thing is just making it easy for a software person to go and be like, oh, look, I can build a robot to water my plants, and it's not that hard. Once you get the basics working and you have a normal software platform that uses modern languages, and you can use all your modern tools and all your standard tools that you're used to, then you can go and do a lot of very cool things right after the fact. Right? When you have to spend a ton of work up front to even get the hardware working, and then you're left in a esoteric niche toolkit, you're kind of stuck. Not to talk negatively about things, but a little bit. If you look at Arduino, right? A lot of software people have played with an Arduino, and it's a very great platform, and you can do a bunch of cool stuff with it very easily, and connect hardware to an Arduino and update the code on the Arduino and make stuff happen. But now you're in this Arduino land. Now, if you want to use a standard tool, maybe you want to use a cloud machine learning offering. It's very complicated to do that. Whereas if you can just use a normal computer, like a Raspberry Pi, and a normal programming language that you're used to, with normal tools, then you can go and use all the other tools that you've been using for your entire career to go and make that hardware do more interesting things.
Mm. And would, for example, from the point of view of the hardware itself and the different elements that can connect, for example, to the Raspberry Pi part, would, for example, VM, how would the process of starting with VM look like? Would I just install VM on that Raspberry Pi and it would automatically recognize, for example, all of the hardware parts and kind of make them accessible?
So you install VM on the Raspberry Pi, and then in our UI, you configure what hardware you have.
Mm.
But it's pretty straightforward because you know what hardware you have. You know if you've got a certain motor, so you basically just go and configure the hardware. There's a lot of tutorials, and you connect it. And there are tutorials to tell you, like, hey, if you want to build this, maybe go and buy this kind of a motor and connect it to the Raspberry Pi this way, and then here's how you configure it. And there's no code to write. It's all very straightforward. You can do it in JSON or using our UI tools, and you can get up and running very quickly.
Mm. And I've also seen quite a couple very interesting projects on your website that have been using VM for real world and for solving the real world problems. And I was wondering which one of them is your favorite or the most interesting that you would call. What do they do?
Are you referring to the customers on our website?
Mm-hmm.
Sorry, I don't know which one's on our website. Not everything is public. So, one of the ones on our website is Dexi Robotics, and they make salads. And I am very interested in everything in that space because I think that more people should have access to higher quality food options whenever they need. So think about salad making. Obviously, people can get salads. And if you go at lunchtime, you can get a salad. That's great. What if you're at an airport at 7 p.m. or 8 p.m. and all of the restaurants are closed and you want something healthy to eat? As someone who's been in airports a lot late at night or early in the morning, you often are left with very few options. Same thing with hospitals, right? I have someone who's been in the hospital and tried to eat something at 3 a.m. You're left with candy bars from a vending machine.
Yeah, I've seen that.
Not exactly a great thing. So if you have a robotic solution for making fresh salads, then 24/7, I can go and get a salad. When you start extrapolating from there, it changes a lot of things, right? You can bring costs down. You can, bring access to higher quality food down.
Yeah.
And, food's sort of a pretty universal concept. And I would love for more people to have access to cheaper, higher quality food options.
And the company that creates the salad making robots, what's their process? Because, for example, if you look from perspective of a software engineering project, imagine I'm building a new application that I'm going to deploy. I can use certain tools to create a CI/CD pipeline to kind of have the entire process automated and to publish the app into the production. And I was wondering, from the point of view of robotics projects and how they use hardware, how do they tackle, from a point of view of kind of software engineering as well, but how do they tackle automated testing of those robots and kind of the entire process of getting the product from scratch into the hands of the customers?
Yep. So one of the core principles of VM is how do we make that easier, right? Obviously, doing continuous testing on a physical robot's tricky. So you want to enable that, but you also want to make it easy to do sort of standard standard software things like mocks. So making mocks of hardware in VM is easy, and we have default mocks for lots of hardware also that you can use. Testing on old data is really easy in VM. So you can sort of get data from cameras, whatever, store it, and then test on that data. So you can test all of your code in a continuous sort of testing methodology. We also make it easy to take your code and deploy it to robots, whether it's locally, in your lab or out in the field. And you can deploy like a couple of robots or 50% or your entire fleet, right? Because, there is no other way to actually know if it works than actually trying it. And so we make this whole life cycle thing much easier. And in VM, it looks very similar to what you'd expect in any other sort of software toolkit, right? If you're deploying code to AWS, maybe you're using AWS Lambda, and how do you test that, right? It's not exactly the same, but philosophically, it's very aligned to things like that. How do you test it like there? How do you do it with tools and CLIs and systems that are very similar to any software engineer?
Because most probably you can just test the software, the components itself separately as well, partially. But when it comes into the real world, you might run into completely different issues that, are of a physical nature as well.
Correct. And I think, one of the things that we fundamentally believe is that we want more people testing in the real world, because the real world is too complex for software to really emulate at this point. We don't have a full physics simulation of the entire world. It's pretty complicated, and we want to make it really easy to test in the real world.
I remember one of the robotics university projects I was doing was kind of an A4 piece of paper with a labyrinth on it, and we had an A-star algorithm. So we had a camera scanning it, and then an A-star algorithm kind of trying to find a way out of it, and then we had a pencil with a machine that was moving around in 3 dimension that was actually physically drawing the way out. What it turned out is that as soon as the pencil was getting closer to the paper, because it was a step motor, it would tear through the paper with the pencil. So whatever we have created in the beginning, we had to build very ad hoc suspension mechanism to actually make sure that it doesn't, and destroy the entire paper that was provided. So that's obviously like,
Yep.
so, and simple stuff like this can actually really, really get into the way.
Yeah, exactly.
Which is like a example.
like you have to, and there's a million examples that are like that are very similar, and that's why making it easier to test, making it easier to iterate, so that your iteration cycles go down. One of my big beliefs about software, hardware, anything where you're building something, is one of the biggest indicators of success is iteration time. How long does it take you to put something and try it, get feedback from that, whether it's your own or someone else's, iterate and try again. As a software person, when we were working on MongoDB, if it took us an hour to try some code change and run it through our tests, it's very hard to make things happen quickly. If you can bring that time down to 5 minutes, 2 minutes, 10 seconds, it completely changes the way you think about writing software. It makes everything much easier, right? You can imagine, right? If you change one line of code and to test it takes an hour, that's a nightmare, right? That's kind of a hellish world to live in. And in the robotics world, that is sort of the standard, right? Where sometimes it's an hour, sometimes it's weeks or months. Right? It's very hard to actually make progress in that world. You want to be able to go as fast as possible.
So removing as many of those bottlenecks will kind of bring us up to speed as much as possible as well.
Exactly.
And I was wondering, could you tell me a little bit about what do you do in the area of edge computing with VIAM? Because that was mentioned as one of the use cases, and I was just wondering, how do you, what do you do?
If you think about robotics, right? Robotics is sort of fundamentally the edgiest of edge computing. So everything in VIAM, right? There's always a robot somewhere in the real world. Let's just make a simple example. There's a robot in your house watering a plant, right? So maybe there's a Raspberry Pi connected in your house, it's connected to Wi-Fi. So there's a lot of software that runs on that Raspberry Pi. There's the stuff that connects to the hardware, or there's any algorithms you want to run there. There's also stuff that can run in the cloud, where maybe the UI is in the cloud, cloud configuration, logging. Maybe, let's say you're doing machine learning to detect if a plant is healthy or not. You would probably want to build new models in the cloud and use bigger compute there. But then you want to actually do the inference on the cloud, because you don't want to send every picture of your plant up into the cloud. Maybe you never want the picture of your plant to ever leave your house. Maybe your plant doesn't matter that much. But if you're thinking about, hey, is my pet healthy? Okay, maybe that data you never ever want to leave that Raspberry Pi. And so you do all the inference, actually the application of the model locally, and then just metadata, just like, hey, there's a problem, go send someone an email. That's what gets sent to the cloud. So the entire notion of robotics and the platform is very related to edge computing. We don't really think about it in terms of edge computing, because everything we do is on the edge
Hmm.
fundamentally.
Yeah, because obviously training anything on the robot itself, that wouldn't make sense. But for
Right. And look, there are places where maybe you want to do it, but almost in all cases you want to do the training in the cloud. Another one where you're building maps, where you're collecting data, moving around, it's called SLAM, and then building maps of an environment. Again, same thing. You want to collect the data on the robot and then use cloud computing, which is much faster to actually go and build maps.
That would make sense. And from the point of view of the customers that use VM, what is the business model behind VM, and how do you guys charge your customers?
Yep. So everything that runs on your robot is open source, thereby free. The cloud is consumption-based pricing. So, for example, if you are using us to build models, we charge you for storing the data, right? If we're storing a gigabyte of data, we charge you a per gigabyte fee. If we're building a model for you, we charge you the compute time for actually building the model. There is no like a per robot fee, there's nothing else. So it's purely consumption-based pricing. So very similar to sort of other cloud computing things like AWS, where if you're using more services, you get a bigger bill. If you're using very limited services, you could pay us almost nothing, or in fact, zero. And there's also a free tier. So very similar to sort of other cloud business, consumption-based cloud computing businesses.
So it's actually easy to start as well, just to try it out in the beginning. And then later, as the business scales, you scale with.
Yeah, you can, when you're in development, you're going to pay us very little, if not nothing, unless you're storing a lot of data.
And what is, from the point of view of the technical challenges, when building VM, obviously it's a pretty vast and large system. What was the biggest challenge that you have encountered while building VM, and how did you tackle it?
The hardest part is we're not doing a lot of hard science, right? The science has been done. We're doing a lot of engineering. The hard part about this space is the surface area is enormous. Think about the number of types of hardware, the number of types of services and things you need to actually go and build a successful business. It's a really wide area. And so the hardest part has been iterating on the prioritization and on what actually matters to our users in terms of being able to actually successfully build a product. And it's not rocket science, it's not hard science, but it is a very hard optimization problem. And then managing a large engineering team that is constantly having to reevaluate what it's working on to make sure it's adding the right value to our users is hard.
And from the point of view of the user request, do you just speak with users, do like a poll, for example, or ask them about what hardware do they want to use the most? Or how do you speak with users and request the feedback from them in order to prioritize those parts?
So we talk to a lot of our users on a weekly basis. We're still small, so we can talk to, it's a lot, but we are trying to be as hands-on as possible. And, we're talking to dozens of people, dozens of different customers weekly. And we also have a Discord channel where we sort of monitor and talk to people and do it that way. I've never been a big believer in polls, but it's really more about, talking to people, whether it's through the community channels, at conferences, just actually talking to customers and trying to collate that as best as we possibly can.
And from the point of view of your team, could you tell me a little bit more about your team? How large it is? And because you also have a pretty good standing within the social media. I really enjoyed your channels both on YouTube and on Instagram. And if you could tell me a little bit more about your team and how do you all work together? And are you all based in one place? Are you more remote? How do you work?
The company's about 90 people right
now.
It is largely based in New York City. We have a headquarters in New York City. We have a lab in New York where we have a lot of robots that we test with, and people can build robots and play with robots and get comfortable testing software on robots. So we do have a headquarters in New York. We do have a handful of people, maybe 10% of the company that is remote. That will probably grow over time and be more distributed over time as our client base spreads out more. And how do we work together? It's relatively standard tech world stuff. Relatively standard. We use Slack for better or for worse. and go from there.
And you've also built a great team at Mongo and now at VIAM. And would there be any advice that you would give to technical managers who are building teams right now, engineering teams, on how to build a great one?
That's a whole conversation in and of itself. But look, at the end of the day, what really matters is getting the people who are good at working in teams, because software is a team sport, and figuring out the right process that works for your team and your business. So, just because, too much process or the wrong process can kill teams, and not enough process can cause chaos. And just getting something that works, that lets people be iterative, but also make sure everyone's doing the right thing and pulling in the right direction. As long as you can do that, you're going to do okay.
And from the point of view of hiring, how do you, what is your recruitment process like? And what do you look for in the potential candidates that you are hiring? And are you hiring now by any chance as well?
We are hiring now across a whole number of different roles. And our process is, again, pretty similar. Like at the end of the day, we look for people who have the right skills, who are smart and can learn, because we feel we always value intelligence and the ability to learn more than any specific skill, because we feel like any specific skill can be learned, but if someone isn't interested in learning or can't learn or isn't creative, it's hard to teach those skills. And we are hiring. We are also, like one of the most important things for us is people who will work well on a team. And, like software is a team sport. At the end of the day, the team matters more than any individual. And so people who are going to add value to the team and make the team build stuff faster, that's what matters.
And from looking at the field of robotics and within the next 10, 20 years, how do you see the field of robotics developing from within the next 10, 20 years? And what kind of breakthroughs do you expect, or what progress?
So the most important thing for me is actually to see way more companies, right? I think what you see is a lot of the science is in good shape, a lot of the hardware is in good shape, but there aren't enough people actually putting it to good use. And the tooling has been too hard for people to actually go and try that. So the most important thing that I want to have happen is people actually to start building companies, putting products into the world, start doing interesting things, small things that actually are valuable, and then keep iterating and keep growing. Right? There isn't a specific thing that has to be figured out or learned or understood. It's really just, hey, what can we do with this new technology, and start making things happen.
Because the field of AI, for example, is accelerating right now very, very fast and just faster and faster. And I was wondering if, for example, in your opinion, the robotics is accelerating at the same pace from the point of view of hardware, or are there any specific developments within the robotics world that you're very excited about and look forward to see them in practice?
So as an example, AI and the robotics world are intrinsically linked. Right? How do you make your robot smarter? AI. Hardware has actually come a tremendous amount in the last 20 years. Right? Robot arms, batteries, GPUs, LiDAR, all these things are way better now than they were 20 years ago, like orders of magnitude better. What's been missing is the glue to link these two worlds together. Right? The software world has improved dramatically over the last 20 years. The hardware world has improved dramatically over the last 20 years, but the tools that link them together have not. And that's what VIAM is here for.
And what is VIAM's team working on right now? And what is next on your plate?
There's a lot of things. It's a big team. But at the end of the day, it's a lot of things, how do we make it easier for people to go and build robots, right? So right now we're working on, for example, a tool to make it easier to build drivers and modules that people want to publish and share it with the community. We're working on more integrated components and more ways that you can add your own ideas into VIAM. We're working on better ways to deploy code and manage code on a very large fleets. If you've got 10,000, 100,000, a million robots, to make sure it's really easy to manage versions and understand what's happening, do remote diagnostics, remote debugging of, a million robots in the field. A lot of things like that.
What would be an example, for example, in practice of a large robot fleet? what would be the most common kind of use of the large numbers?
Yeah, so the most, I mean, this is not a VM project, but the one that everyone knows about is a room, right? There are
Yes.
millions of Roombas deployed in the world. That is a very large robotic fleet. I mean, another one that's a little bit different, but to broaden your sense of what a robot could be, is all the Nest thermostats.
Mm.
Nest thermostat, right? It's got a temperature sensor.
Mm.
It's got a way to turn on and off the air conditioning or heat, and it's operating independently 24/7. Right? It doesn't move around, but it's 100% a robot.
Mm. This is correct. I'm actually sitting under an aircon that's controlled remotely as well. So we have a separate
There you go.
a separate web application, and it's incredibly annoying. It could definitely use a little bit more work, but I don't think I can go and code it up over there to fix it.
Right. So one of the things in VM is that everything is web connected
Mm.
optionally. And we have things like, because we use standard tools, we have a Flutter SDK. So for any web or mobile developer, and we have a TypeScript SDK and a Flutter SDK. So let's say any mobile developer who wants to go write a Flutter app to control anything that's in VM is just going to use a standard Flutter API and can use any standard Flutter tools and go build an app.
So, for example, as your customers who actually build the hardware connected to VM and present it later to their customers, that would also enable their customers to extend it further.
Correct. If they want to, everything can be API driven.
That's great. Because actually, yet again, with the toy example of my aircon, I had to write a tiny script, actually inject it into the web app in order to click on some buttons to stop the aircon, switching off the entire time. And as a founder of VM, what is your ultimate vision of the platform? Imagine that you wake up tomorrow and everything that you wanted to do with VM, it could be done. What would be the ultimate vision of the final product?
At the end of the day, right, what we really care about it, we want to make it really easy for people to start with hardware, connect it to a computer, start writing applications, make it really easy to go iterate quickly to have a product in the field, make it easy for businesses to scale and build more robots, get them, mass produce them, get them to the field, iterate on them quickly once they're in the field, and productively and efficiently manage very large robotic fleets. When that happens, we want robots to be a standard part of people's daily lives. There are no robots wandering around fixing potholes right now. There are no robots actively cleaning oceans. There are no robots actively planting trees, right? There are projects, there are experiments in these areas, but no production, nothing's in production. Why not? Right. So what we care about is all those things actually happening in the real world all the time.
So you look more to empower the companies that are building their own products on top of.
Exactly.
Yeah.
Exactly. We want an entire ecosystem of robotic companies solving real world problems. And, just like with MongoDB, I don't know what people are going to do with the platform. Hopefully, I've got ideas, I've got things I want, but I assume that a lot of smart, creative people are going to come up with lots of great ideas about things they can build and things they should build. And I hope they go and build them.
So because I could see the parallel here as MongoDB has empowered a very large number of developers and to build their applications on top of it and companies. And the same with VM potentially within the robotics space.
Exactly, right? Everything we do is to empower other developers to go and build businesses, to go and build robots that do interesting and useful things in the world.
And from the point of view of the learnings that you have taken from MongoDB as you're applying them right now in VM, what would be some of the most important things that you're taking over from MongoDB from the point of view of philosophy and how to run things to VM?
Yeah. So the most important one is that if you don't have people using your product to do useful things, you haven't really accomplished anything. Right? I don't care how much software you've written. I don't know how cool it is. I don't care how pretty it looks. If there isn't someone actually using it on a daily basis to make their job easier, to actually do something useful in the world, you haven't done anything. So you've got to start with users. And number two is you've got to bring your entire team into that journey and make sure they understand why people are using your product, what they're trying to accomplish, and how you make it easier. and how you make it easier on a daily basis and not just, theoretically, how you actually are making their job easier.
Do you think that that potentially as well, from looking at the robotics companies that are starting right now, would you think that the cost of the hardware might be a very big a very big step for the companies to get into the field?
Hardware is not that expensive these days. It depends on what you want to do, right? Obviously, there are things that are more expensive, like robot arms are expensive. Other things aren't that expensive. So it really depends on what you're doing. There are a lot of things you can do with not a lot of expensive hardware. It also means that, or to raise it another way, a lot of hardware has gotten very expensive or is very expensive because the hardware has to be almost perfect because it's really hard to write good software. One of the things that we're enabling is that you can use more commodity hardware and use software to make it better, right? Let the 30 million software engineers in the world take commodity hardware and write code to make it actually do really hard things. That will bring all the costs down even more so than they are today.
And what would be your advice for founders who would like to start robotics companies in 2023?
First, talk to us because we'll help. Two, and not just on like using VM, like I'm just like, hey, like what hardware you use, all those things. Two is, find a problem. Don't, focus on the problem and the business case. And there's a lot of things people think that I think are incorrect. For example, having to make robots fully autonomous to start. And one of the best things people could do is think about problems from a business standpoint of, hey, maybe I can have someone helping this robot when it gets stuck. And I don't have to make it perfectly autonomous. I need to have all the sensors in there so I can have someone help it remotely from an office or from around the world, collect all that data. And then we talked about AI before, use AI to continuously make the robot better. And maybe in the beginning, someone needs to manage a robot half the time. Maybe that's okay. Maybe in 2 years, it's 10% or 5%. And what happens is your efficiencies grow over time, but don't assume you have to make it perfect or fully autonomous on day zero, right? Like let people help the robots.
From point of view of so me, for example, imagine if I would want to start a new robotics company, something that moves around, let's say at the office, like a Roomba or does any other manual thing. Would there be any because you said to improve those robots as they go, right? So like in a more in continuous improvement, wouldn't this potentially pose any safety issues? Or are there any certifications that you need to get first to make sure that those robots are safe and that any kind of malfunction won't cause any problems?
Yeah, I mean, there's a variety of things, and every electronics device that gets sold in the United States has a certain certification required. Same for Europe. So there are certifications you need. If you think about, and that sounds daunting from a software engineer standpoint, but if you think about the number of relatively cheap pieces of electronics you can buy on Amazon, they are all certified. It's not nearly as onerous as it sounds. It's just not a skill set that most software engineers have or know anything about, but it's actually not that hard to do it. In terms of safety, yeah, of course, anything running around your house needs to be safe, and you need the right tools to make it safe. You need the right tools for security and privacy, right? Those are all sort of built into VM. Anything with a camera in your house, privacy has to be paramount. Security has to be paramount. A related space is IoT, which has not had a great security story to date, and is huge number of issues. And one of the things that we do at VM is to make sure that everything is secure and very private out of the box, so that you can do things very nicely.
I was thinking also about all the other devices that are within the home recording as they go, like the smart TVs, for example, and then potentially uploading it somewhere at the same time. So I do agree with this part on the safety. Yeah. And what would be your advice for software engineers who aspire to become CTOs or technical or successful technical leaders in the future?
I would say just start, right? Like with anything, the hardest part is getting started. One of the things that we've done is publish a bunch of very simple tutorials that any software engineer could do, and like just try it, right? See how easy it is to get started, and then think about problems that you care about that maybe don't seem enormous, but like, hey, look, that would make things better if I went and built something to do that.
Cool, awesome. Thank you so much for your time. It was great talking.
Yeah, thanks a lot. This has been really fun, and hopefully we'll talk soon in the future.
Talk soon. Okay, thank you so much.
All right, have a good one.